Hello guys, welcome to this new video on AI and machine learning. In this video, we are going to learn something about sentence transformer in NLP. So, let me give you a quick introduction about what sentence transformers are. So basically, sentence transformers is a Python-based framework for state-of-the-art sentence, text, and image embeddings. So what can we do from sentence transformer? This embeddings can be computed using the text and images, and they can be computed in many languages. Along with that, you can do common tasks like semantic text similarity search, semantic search, paraphrase mining, then you can do text clustering, image clustering, and so on. So there are a lot of applications that sentence transformer can be used for. So I have noted down some applications here, and we will be performing them live in this tutorial and see the magic of sentence transformer. So firstly, I have mounted the drive. Now to install sentence transformers, you just need to install it using the pip command. So I will install using pip install and sentence transformer. This is the command. So once you have it, so by the way, sentence transformer is based on PyTorch and TensorFlow. So it will automatically install those pip commands. Cool. So once sentence transformer is installed, now you can start writing applications on this sentence transformer. So the good thing about sentence transformer is that it provides us with a lot of pre-trained models, which you can use for your application. Along with that, you can even fine tune them very easily. So here are some pre-trained models that I'll be using. So for the first application here, first we will be seeing how you can make embeddings out of text using sentence transformer. So it is pretty simple. From sentence transformer, we import sentence transformer. In that we pass the model name. So here we have the model as paraphrase mini LM 6 L6 V2. So if you want to see the application of each and every model, you can go on the sentence transformer website, and then you can see what are the parameters that are present in this pre-trained model. So once we have the object for this sentence transformer, then we have here a list of text that you would like to encode. So here it is written Python is an interpreted something something. So we have a bunch of text and just pass the sentences in this model object that is created above, and the embeddings will be there. So now let's see how much time it takes to load the model and give us the embeddings. So you will see that first of all the model will be downloaded from this pre-trained paraphrase LM L6V2. Once that is done, then it will start encoding the model, and once that is done, you will get the embeddings in the form of numbers, and you can see how they look like. Now once you have the embedding, then you can perform more complex tasks like clustering, or you can perform similarity or something like that. So because embeddings is what is embedding basically, it is that you convert data from one form to other, data like text or data like images or data like video into numbers basically. So this is how you can create embeddings out of it. Now let's see how it does with semantic textual similarity. So for that we from the sentence transformer we will need the sentence transformer. Along with that you can import this util method also. So the model is created, then we have here some sentences. So the sentence is Shabir is a good boy, Shabir is a very well behaved boy, and the quick brown fox jumps, blah blah blah. So you see that first two sentences are very close to each other. That means there is some kind of textual similarity between these two sentences. Correct. So can sentence transformer identify that? So what you can do is that in the util method that we called here, you can call the cosine similarity, and you can pass the embeddings one by one. So here it will check for the first sentence and the second sentence, and first sentence and the second, this and this sentence. So let's see what is the similarity. So it clearly shows us that similarity between the first and the second is very high, that is 83%, almost similar, whereas the similarity between this and this is not that great. So the similarity is very less. So this is how semantic textual similarity can be done in sentence transformer. Okay, the next is semantic search. So again, to do semantic search, we have the sentence transformer object. We have the util method here. We create the object. Then we have a corpus of text. So here there are a bunch of text which has Python, something related to Python, something related to Python, something related to a fox. Then first of all we encode them using the sentence transformer. Then we again have a query, still a query object here. So the query object here is what is Python. So we can actually pass multiple query object, and we can create the corpus also multiple in the multiple lines. There is no compulsion that it should be this much long or this much long. It can be very long also. There is no problem in that. So once you have the queries also, you need to encode it using the model. Same with the corpus, you need to encode it, and then you can use the util.semantic search. So semantic search is an internal method from the util class. And you pass the two objects here. One is the query embeddings and other is the corpus embeddings. And you want the top two, right? We want the top two closest semantically similar to what is Python. And what does the brown fox do? Correct. So let me just increase some of the inputs here. Right. Right. So once that is done, now let's see if it is able to get us. So for the first query, what is Python? It showed that I love Python is 70% similar to it, and it fetched that sentence out. Second, very most similar is Python is an interpreted high level general purpose language. So it showed that okay, this is the second thing to it. Correct. What did the brown fox do? For the second query image, we have the brown fox is dead and the quick brown fox. So this is like 48% similar, this is like 38% similar. So this is how you can search things using sentence transformer in semantic way. Now other is paraphrase mining. So what paraphrase mining means is that, like let's say you have corpus of text. Now what text belongs to, like what kind of text are very similar to each other. So here we have a new model here, all mini LM L6 V2. Then we have the list of sentences using util method. We call the paraphrase mining. So we call the paraphrase mining. We pass the model and we pass the sentences directly. And now let's see how the result is. So first it will download it and see now the top five paraphrases. Now this two sentences, the new movie is awesome. The new movie is so great. They are very similar. Out of the total what we had passed, so they are like very similar in terms of meaning also. So it created that this paraphrase are very similar. Now this paraphrase, which is the cat sits outside, the cat plays in the garden, they are also similar, but if you see the similarity score, it is not that great. Similarly, if you see this last one, that is I love pasta, the new movie is awesome, there is not much similarity in them, correct? But still it has some kind of similarity. But if you compare it to the other paraphrases that has given high similarity, the similarity here would be low. All right. So the next application is on image searching. So to search image, we have the clip with B32 model here from the sentence transformer. So this is with respect to, like if you want to work with images and video, you can use the clip with B32. So we create the object of the model. Then first we encode the dog image that we have here. So let me show you the image. So this is an image of two dogs running in snow. Alright. So I want to search that which text is very similar to this image. So I have three texts here: a dinosaur laughing, two dogs in the snow, and a picture of London at night. So this is also encoded using the model. You see, now two objects we have. One is image embedding, one is text embedding. And with the util, you pass that cosine similarity of both of them, and you get the cosine scores of them. So let's see which of these text is very similar to the dog image. Okay, so now the image embedding is taking place with the it shows that okay, out of this three text, the second text is very similar to the image that is passed because it gave a similarity of 32%. So the two dogs in the snow, and that was the correct answer, right? We saw the image also; it was two dogs in the snow. All right, so these were some simple things that you could have done with sentence transformer. There are also other applications that could have been done with the help of sentence transformers. So you can try check them out. So now we will see a very simple project of clustering using sentence transformer. So For that, we have some data set from Amazon. So, like the data set is actually very huge, but the corpus that we'll be using just to show, demonstrate like how clustering works here. So, I'm just considering 200 text for that simplicity purpose. So, for that, I installed the dataset. Then some basic dependencies, and from dataset we have this load dataset method here, which is going to load the dataset of this Amazon polarity, and we are going to take only the first 200 records to keep the clustering simple. All right, so that is done. Now let's see the corpus. So the corpus is of text. Obviously, it will be of text. So this is the text in the corpus, and we have around 200 records in the corpus. Now let's try to cluster this out. So from the sentence transformer, we have this model paraphrase distilled Roberta base P1. So we'll create the model here. Then after downloading the model, we create the embeddings for the corpus that we downloaded. So we have 200 records, and this is how it looks like. Now simply using clustering. Now to cluster it, we are using the k-means clustering from sklearn. So we want to cluster it out into five basic clusters. So the k value is 5. Okay, that's done. So now let's see. So in every cluster, we have like around 61 equal amount of, not equal, I can say, but the clusters are like divided. Now let's see how the cluster looks like and how they are. Now to see the center part of every cluster, what was the text in the cluster? So this is just the code for that. And you see that the center part of every cluster has this type of story. So they are like clustered down into five clusters, which will be having similar meaning. So these are some of the applications that you could have done using sentence transformer. There are a lot more, but they are not like I can't cover each of them in one video. The goal of this video was to show you how amazing sentence transformer is and how easy it is to work with it with the help of Python. And let me know how you use it in your day-to-day applications. And if you have any other doubts regarding it, feel free to ask in the comment section below. So enough for this video. See you next time.